Question 1. The straight metal arm of a windscreen wiper on a car rotates in a circular motion from a pivot point O through an angle of 140 degrees. The windscreen is cleared by a rubber blade of length 46 centimeters that is attached to the metal arm between points A and B. The total length of the metal arm OB is 56 centimeters. The part of the windscreen cleared by the rubber blade is shown unshaded in the following diagram. Cool. So first things first, I like to highlight or underline the important information in the question. So let's do that. So this angle of 140 degrees, that's going to be helpful. The rubber blade being of length 46 centimeters is going to be helpful. And the total length of the metal arm OB being 56 centimeters is also going to be useful. So we'll highlight all that, or in an exam, underline, or whatever suits you. And so this is so part of the windscreen cleared by the rubber blade is shown unshaded. So that's that little region there. Cool. Part A asks us to find the length of the arc made by B, the end of the rubber blade. Okay, so that's going to be this arc here. This big one there. All right. And the way we're going to calculate that is using the arc length formula, or length of an arc formula, which is in your formula booklet, which we'll write down here. So part A. And so it's L for the length is equal to theta over 360 times by 2 pi r. Okay. I will stress that theta has to be in degrees for this, and the r stands for the radius of the arc. Right, so, and we were told in the question, we know that theta is equal to 140, okay? And r is equal to 56 centimeters, because we're taking the full, we're going from O to B. All right, so we need the full length of the metal arm, which is 56 centimeters. Okay, so now we're just going to bung these into our formula and put it into our calculator, and we'll have the answer. So we'll go L is equal to 140 over 360 times by 2 pi times by 56. Okay, now I'm pretty sure I've already got that in here. Yeah, we'll do it again now. 140 divided by 360 times by 2 lots of pi times by 56. Okay, gives us 136.8333 So what we'll do is we'll go 136.833. Okay, so these dot answers, just so you know, is it's completely unrounded. So this is just literally writing the answer or the number to the third decimal place, but not rounding to the third decimal to 3 decimal places. Okay, and then in normal IB fashion, we will round this to 3 significant figures, which will give us 137 centimeters. And we'll write the 3 significant figures down there. Okay, cool. That's part A done. That's the answer there. So let's charge on to part B. What have we got? So we've got to determine the area of the windscreen that is cleared by the rubber blade. So area of the windscreen cleared by the rubber blade. All right. So we're going to do a bit of thinking here. So we want to find this area here. The way we're going to do that is we're going to calculate this total area here. All right. All of this. And then what we're going to do is subtract, you can't really see that very well, but yeah, subtract this little area in here. Okay. And so in order to do that, we're also going to need to know what OA is, or the distance between OA. And if we see that O to B is 56 and A to B is 46, that means in here, this would have to be 10, right? Have to be 10 centimeters, right? So O to A is equal to 10 centimeters. And that means now we can calculate the area of the smaller sector, the small sector, and we can calculate the area of the big sector, and we'll go area of the big sector, subtract the small sector, and then that will give us the area of the windscreen. Okay, so let's go and do that. Oh yeah, we'll just leave our drawing on there. Right, so the area of a sector is also in your formula booklet, which I'll write here, which is A is equal to theta over 360 times by pi r squared. Same just as before, theta's got to be in degrees and r is the radius. Okay. Yeah, that's cool. So what we're going to do is we're going to say, so theta for our big sector and theta for our small sector, these are going to be the same. These equal 140 degrees, right? But our r for our big sector is 56 centimeters, and the radius, so I should have said radius for our big sector is 56 centimeters. And the radius for our small sector, which we calculated before, which was OA, is 10. All right, 10 centimeters. Okay, so we're going to need the big sector, subtract the little sector. So this is going to be A is equal to, so if we're going to put all the information for the big sector in, we've got theta is 140 divided by 360 times by pi multiplied by 56 squared. Okay, and now we're going to have to subtract the smaller sector. It's going to be exactly the same thing, but we're going to change our r from 56 to 10. All right, and then there we have it. All right, so let's go and do that. So I'm going to go 140. Actually, yeah, we're going to need some brackets here. 140 divided by 360 times by pi times by 56 squared. Okay, cool. Subtract now. 140 divided by 360 times by pi times by 10 squared, which I could have just put in 100, but let's do that. And so, yeah, there we have our answer. We got 3,709. In fact, we'll bring this down. I still got my red pen. Yeah, cool. So equals 3,709.173 ... All right, and so then in normal IB fashion, we'll round this to three significant figures, and so that's going to give us 3,710 centimeters squared. All right, and that is the answer. Question 2. A group of 130 applicants applied for admission into either the arts program or the sciences program at a university. The outcomes of their applications are shown in the following table. Okay, find the probability, so part A says, find the probability that a randomly chosen applicant from this group was accepted by the university. Cool. Right, so this is regardless of whether they were accepted to the arts program or the sciences program, just purely that they're accepted to the university. All right, so let's highlight some important information in the question. The only thing really we need to take from here is that we're given the total number of applicants, which is 130. It's somewhat kind that the question has put this in for us. If they hadn't, which they easily could have just left that out, the way we'd find it out is just by adding up all these numbers here. And you'll see if you do that, they'll add up to 130. Right. And so in order to find the probability that a randomly chosen applicant was accepted, what we're going to do is just add up the numbers of the accepted applicants, and we'll divide that by the total number of applicants, which is 130. So let's bring this down. Let's go here. So we'll go here. So the probability someone was accepted is equal to the number of accepted applicants. I'm just going to write that there. Cool. Divided by the total number of applicants. Right, so that blue stuff is just for your understanding. Okay, you wouldn't have to necessarily put that in an exam, but this here would be what you'd probably want to put in an exam. Okay, so the number of accepted applicants, if we go back up here, we've got 17 in the arts program and 25 in the sciences program. So we'll add those two guys up. We get 17 plus 25 all over 130. That is equal to 42 over 130. And we can simplify this down to 21 over 65. Sweet. And I would leave that as my final answer. You are more than welcome to put it in as a decimal if you wish. That would be 0.323 to 3 significant figures, though this fractional answer is exact. It's the exact answer. And so I would tend to suggest leaving it as a fraction is more accurate. So yeah, we'll leave it like that. Cool. Now let's go up and start with part B. An applicant is chosen at random from this group. It is found that they were accepted into the program of their choice. Find the probability that the applicant applied for the arts program. All right, so this is essentially a conditional probability question, though we don't need to bring the formula over or even use the formula because we've got the exact numbers of the applicants for each category, which will make our life a bit easier. So they were accepted. So that's our condition, were accepted. And we've got to find the probability that this accepted applicant applied for the arts program. All right. So we're going to be taking the number of students that were accepted into the arts program, which is 17 here. Let's get rid of our highlighter from last time. Okay, so the 17. We're going to divide that by the total number of students that were, applicants that were accepted. All right, so let's go bring that down here. And in terms of mathy speak, we'd say the arts applied for arts given they were accepted. So this is going to be equal to the number of applicants, number of arts applicants that were also accepted, of arts and accepted. Yeah, we'll write it like that. Okay, divided by the total number of accepted applicants, which we'll just take here. All right, nice. And so we'll bring this down here, go into red. Okay, so this is the number of arts applicants that were accepted was 17. All right, and the total number of accepted applicants was 17 plus 25, which we have solved in the last question, but I will write it fully out. So we'll say 17 divided by 17 plus 25, which equals 17 over 42. Now we can't do any simplifying with that, so we'll just leave it like that. And if you wanted to leave it as a decimal answer, you could. 3 significant figures, which would be 0.405. But yeah, I'd recommend just leaving it as a fraction is fine. Okay, well, I've not put a B here. Okay, let's charge on to part C. Okay, so 2 different applicants are chosen at random from the original group. Find the probability that both applicants applied to the arts program. All right, so we got 2 different applicants are chosen. All right, and we've got to find that both applicants applied to the arts program. Okay, so in order to find the probability of the first one we chose, or just one applicant, the probability that one applicant applied to the arts program, what we do is we'll take the number of art program applicants, which would be 17 plus 24, and we divide that by our total number of applicants, which was 130. All right, cool. So that will give us the probability of our first one. So let's put that in, and then we'll talk a little bit about the second one. Okay, so we're finding the probability that our first randomly chosen applicant applied to the arts program, and we're going to have to multiply this by the probability that the second randomly chosen applicant also applied to the arts program. So as we said before, we can do our first bit here. So that was going to be 17 plus 24 over 130. Now, in order for us to calculate now the probability that the second applicant also applied for the arts program, and stressing the fact that they're different, we're going to have to remove that first applicant from the pool or from the group. Okay, so they're no longer, we can't choose them again. Okay, so it's basically without replacement. Probability, lots of probability courses talk about that, with and without replacement. So this is without replacement, right? So essentially what we're going to have to do now is subtract 1 from the total number of arts program applicants, and additionally subtract 1 from the total number of applicants. Okay, so if we bring that down here, we're going to have 17 plus 24 minus 1, all right, and then also 130 minus 1. All right, and now if we sort this all out, what do we get? 41 over 130 multiplied by 40 over 129. Now, if we put this into our calculator here, we'll go 41 divided by 130 times by 40 divided by 129. And that would give us this answer here. So we could put that in and round it to 3 significant figures. I know most of your calculators will probably do this for you, but if you wanted to keep with the idea of leaving fractional answers, they are more accurate. They're exact answers. We could just find the product of our numerators, which is going to be 1,640, and divide that by the product of our denominators, which will be 130 times 129, which gives us 16,770. And now if we divide both of these by 10, we can simplify it down to 164 divided by 1,677. And yeah, there you have it. That is the answer to question 2. Question 3. The owner of a convenience store installs 2 security cameras represented by point C1 and C2. Both cameras point towards the center of the store's cash register, represented by the point R. The following diagram shows this information on a cross-section of the store. Cool. The cameras are positioned at a height of 3.1 meters, and the horizontal distance between the cameras is 6.4 meters. The cash register is sitting on a counter so that its center R is 1 meter above the floor. The distance from camera 1 to the center of the cash register is 2.8 meters. Okay, and all nicely shown in this diagram above. All right, okay, let's underline or highlight important information. So the fact that they're at a height of 3.1 meters is going to be helpful. The distance between the cameras is 6.4 meters. Okay. The center R is 1 meter above the floor. No, and camera 1 to the center of the cash register is 2.8 meters. All right, sweet. That will get us started. And part A is asking, determine the angle of depression from camera one to the center of the cash register and give your answer in degrees. Right. Okay. So angle of depression. Now, when you're finding an angle of depression or elevation, make sure that you always take your angle from a horizontal line, all right, not a vertical line. Very easy mistake to make, but yeah, always from a horizontal line. So the way I like to foolproof this is to just draw a horizontal line on my diagram. That's where I'm going to be calculating the angle from. So we're going from C1, so I'm just going to draw a horizontal line going through C1, although that's not quite perfect, but yeah, we'll go there. Cool. And what we're trying to find is this angle in here. All right, so let's label that theta. And let's zoom in a little bit. All right, so there's a couple of ways we could go about finding theta here, but the easiest way would be to form a right angle triangle. So we draw a line that goes through the center R of the cash register. All right, and now we've formed a right angle triangle here. Oh, what have I done? There we go. Okay, so, and we've got the hypotenuse of this right angle triangle. That's this line here, 2.8. All right, and we don't know this side here. We could find it out, but the easiest side to find is going to be the height. It'd be this side here. Okay. Now, given that we have the height of the cameras being 3.1 and the height of the cash register being 1.0, that means the length of this line here plus 1 has to equal 3.1. They have to be the same. All right. So that we can go through that and we can figure out what that's going to be. So this side is going to be 3.1 minus 1, all right, which equals 2.1. All right, and so there we have the height, or let's say the opposite side to our angle theta. All right, and so now we can go about calculating what theta is, or the size of the angle theta. All right, and what we're going to be using is SOHCAHTOA, and specifically sine, because we have the opposite side and we have the hypotenuse. So let's come down here and let's charge on. So part A. So we should be all familiar with the idea that sine theta is equal to the opposite side to theta divided by the hypotenuse, right? And so then, therefore, that's what these three dots mean. They mean therefore, okay? Theta will equal inverse sine of the opposite side divided by the hypotenuse. Cool. And there we have that. All right, so we know our opposite sides. Let's just write this in. Op was equal to 2.1, and the hypotenuse was equal to 2.8. All right, so then theta will equal the inverse sine of 2.1 over 2.8, which I believe I've actually got here. Yeah, so I've already put that in here. So inverse sine 2.1 divided by 2.8. So that gives me 48.5. Yeah, let's put this, we'll put a ... answer, which is then completely unrounded. Here we'll go 0, ... And then in normal IB fashion, we'll round this to 3 significant figures, which is going to be 48.6 degrees. Okay, and there is the answer to part A. Okay, on to part B. Calculate the distance from camera 2 to the center of the cash register. All right, so there's a couple of ways we can do this. The most efficient way will be to use the cosine rule to calculate this. All right, so we can form a triangle with the length across C1 and C2, the distance between those, which we know, just given the question, which is 6.4. It's going to be the same as the distance on the floor. So that's 6.4 up here. All right, and we know that this angle in here, we calculated that was 48.6 degrees. All right, and so then now we can use, the cosine rule to calculate the length of C2. All right, I'm going to write the cosine rule down here for us. Okay, so cosine rule is C squared is equal to A squared plus B squared minus 2AB cos C. All right. So talking about the elements from this formula here, okay? So, or the rule, I should say, the sides that you name A and B don't really matter so much. It's just you need to make sure that you label C correctly, C and the angle C, okay? So if we go back up here, angle, so the only angle we know is this 48.6, right? And so that means this line, which we're going to be trying to find, the distance between C2 and R, will have to be our lowercase c, or our side C, right? It has to be opposite to the angle that we're using, right? And then now whether we call 6.4, this side 6.4 A or B, or this 2.8 A or B, doesn't really matter, okay? So we can say, this side is A, this side is B, or vice versa, right? So we've got and then our angle here, this is going to be equal to capital C in the formula, right? So if we bring that down, so we're going to say that A is equal to 6.4, say B is equal to 2.8, and C is going to be equal. Now we can use this 4.86, though this is a rounded number. So I would, to avoid what some people call premature rounding, I'm going to say, why don't we use our full expression here for C, or for the angle, which is the inverse sine of 2.1 over 2.8. Now, the thing is when I use this, that means it's going to give me this full answer of 48.59, so on and so forth, all right? And it will save me from potentially making a mistake where, I round too early or use rounded answers in my working for a next question. All right, very easy mistake to do. Very easy mistake to make, yeah. So let's charge on. So we have, so C squared can equal 6.4 squared plus 2.8 squared minus 2 times 6.4 times by 2.8 times by cos of this big thing here. So we'll go sine inverse of 2.1 over 2.8. Oh, I've lost the top of my square bracket. And then, there we have it. All right, nice. So let's put this all into our calculator, and then we'll have to square root it to find C, and then that will be our answer, right? So let's go through. So I might just, oh no, we'll start again. So 6.4 squared plus 2.8 squared minus 2 times by 6.4 times by 2.8. Now I know your calculators will probably let you just sort of bring an answer carried forward, and you can just put answer. Unfortunately, this calculator is not as fancy, so I'm going to have to go somewhat the long way and go here and then say, what was that again? 2.1 divided by 2.8. Boom and boom. Cool. And so that gives me C squared being, so C squared is equal to 25.094 ... Okay, and so then we can say, therefore, C is going to equal the square root of this answer, all right? And then if you're familiar with your indices laws, all right, to take the square root of a number, you can just take it, put it to the power of a half, or 0.5. So that's what I'm going to do here. Do 0.5, and then that gives me the answer of 5.009. So 5.009 ... And so to three significant figures, we would write 5.01 meters. And there you have the answer to part B. Part C. So here we're asked to, without further calculation, determine which camera has the largest angle of depression to the center of the cash register. Justify your response. All right. Let's stress this idea. We don't want to do any more calculations. Okay. We've got to use we've got to justify our response with, I suppose, intuition. Right. So let's go back up to our diagram here. And let's just visualize, okay, if we were to move, let's draw our horizontal line across C1 and C2, so we can sort of draw in our angles of depression. Let's say we moved C1 over to here. All right, and now we'll draw our new line from C1 to R. Okay, so what we can see, that when we move C1 closer to R, given it's at the same height, the angle of depression gets bigger. All right, and it'll be the same for C2. We put C2 closer, bring C2 here. We can visually see, what am I doing? Wrong color. Visually see that this angle in here now, all right, is greater than that angle in there. Now that one's not quite as clear, but the C1, the moving C1 closer, we can quite easily see that the angle of depression gets bigger. All right, and so that's going to be part of our justification. So if we come down here, we'll say C1 and C2 are at the same height, and C1 is closer to R, hence the larger angle of depression is from C1. All right, and there you have the answer to part C. Question 4. The pH of a solution measures its acidity and can be determined using the formula pH equals negative log to the base 10 of C, where C is the concentration of hydronium ions in the solution measured in moles per liter. A lower pH indicates a more acidic solution. Okay, concentration of hydronium ions in a particular type of coffee is 1.3 times 10 to the power of -5 moles per liter. Right, let's before we crack on, let's highlight our important info. So this formula here, pH is, that pH formula is going to be helpful, and specifically the number here, 1.3, the number of hydronium ions in a particular type of coffee. All right, part A asks us to calculate, the pH of this type of coffee. So relatively straightforward here. We've just essentially got to substitute in this number here, 1.3. This is going to be our C. We just have to substitute that into our pH formula. So without further ado, let's do this. So pH is going to equal negative log to the base 10 of 1.3 times 10 to the power of -5. Okay, let's find out what that is. I'll bring this over. Okay. Oh, whoops. Negative log of 1.3 times 10 to the power of -5. You'll see, I'll put a third one in. You'll see you haven't had to put to the base 10 here because just log, the standard is base 10. So you can just put log. It'll be the same in your calculator as well. The standard log is base 10. And so yeah, there we have our answer. So we'll go 4.886 ... and we'll round that to 3 significant figures. So pH is going to be 4.89, which is, funny enough, factually correct. The acidity of coffee tends to differ from varieties, but it ranges from around 4.85 to about 5.1. So that's cool, factually correct. All right, let's move on to part B. So a different unknown liquid has 10 times the concentration of hydronium ions of the coffee in part A. Determine whether the unknown liquid is more or less acidic than the coffee. Justify your answer mathematically. All right, so if this unknown liquid has 10 times the number of hydronium ions, what we can simply do is what we can call our new C. All right, so our new C for our new unknown liquid, we can say is equal to 10 times 1.3 times 10 to the power of -5. Now, you could probably figure out that that would just change this power here to being -4, which we can do. So times -4 to the power of -4. And then, yeah, we'll just lob that into our calculator and we'll find what the acidity will be. So I'm just going to copy this down here, change this 5 to a 4. Alternatively, you would have been absolutely fine just using this expression here. I just wanted to show you what would happen. Okay, and so let's calculate this. Quite nice, we've still got that in our calculator, so we'll just change our 5 to a 4, and so that gives us 3.886. Okay, and so then, yeah, by 3.886, and so to justify our answer, we can say that 3.886 ... is less than 4.886 ... And so we can conclude that our unknown liquid is more acidic. So if you're familiar with your chemistry and pH scales, ranges from 0 to 14, and acidic solutions or liquids are low numbers under 7. So tap water is 7, or neutral is 7, and then above is alkaline and below is acidic. But this is not a chemistry lesson, so we will just say therefore, so these 3 dots again, that means therefore the unknown liquid is more acidic. Okay, there is the answer. Question 5. A polygraph test is used to determine whether people are telling the truth or not, but is not completely accurate. When a person tells the truth, they have a 20% chance of failing the test. Each test outcome is independent of any previous test outcome. 10 people take a polygraph test and all 10 tell the truth. All right, so let's underline or highlight important information. So we've got a 20% chance of failing the test, even if you tell the truth. Okay, so then therefore we have an 80% chance of passing the test, when they tell the truth, or when these people who are doing the test. Each outcome is independent, right? And we have 10 people taking the test, and they will tell the truth. All right, so we have so there's 2 outcomes in this question. We have passing and failing. Each outcome is independent, and we have a fixed number of trials or of people doing the test, which is 10. All right, so then what this should be indicating to you is that this is a binomial probability question, right? Because these are basically the characteristics, the requirements for a binomial probability question. And the way we denote a binomial probability question is we usually use the random variable x as a bit of a standard in maths. And we put the first number is n, which is going to be the number of trials, and then followed by p, which will be the probability of success or failure. It depends on which way you want to look at it, but that just needs to stay the same each time. All right. So I'm going to head on to the side of we're going to look at it from a passing perspective. Okay. So if 20% chance of failing, that means 0.8 or 80% pass rate. All right, so we're going to say the number of trials is 10. So we've got a fixed number of people, which is 10. We're going to say P is equal to 0.8. All right, so now we can sort of write our binomial distribution as 10 trials with a probability of success or passing it of 0.8. Okay, so part A asks us to calculate the expected number of people who will pass this polygraph test. All right, so let's highlight the expected number of people. Okay, so this the expected number of a binomial distribution is given to you in your formula booklet, which is as follows: is expected number of x is equal to NP. All right, so we can basically bring this over here and we'll say therefore EX is equal to 10 multiplied by 0.8, which equals 8. All right, and so that's the answer to part A. All right, let's move on to part B. There we go. Calculate the probability that exactly 4 people will fail this polygraph test. Okay, so exactly 4 people will fail. Okay, all right. So if exactly 4 are going to fail, then that means you've got to ask yourself how many will then have to exactly pass, or how many will pass. All right, and that means if we have 10, that means 6 will have to pass. All right. So part B is asking us to calculate probability of x equal to 6. Because we're coming at it from a perspective of passing the test, we're trying to be positive, I suppose. You're more than welcome to look at it from a failing perspective, and you put 0.2 here, and then the question would be you put x is equal to 4 in this bit. All right, but yeah, so we're going to come at it from this perspective. Now, if you don't know how to calculate how to use a binomial distribution, or how to calculate binomial probabilities using your graphics display calculator, using your calculator, I would advise you look that up on YouTube or wherever, find a manual and find out how to find binomial probabilities. It's very important for the course. Okay, so I have this little app here, okay, binomial or probability distributions. And so we're going to come down to binomial distribution. We had the number of trials being 10, probability of success being 0.8, and then our number x is equal to 6. You got to make sure that you've got x is equal to here. All right, and there we have our answer, 0.088080. And if we round that to 3 significant figures, we'll get 0.0881. All right, so that will be our answer to part B. All right, so here we go. 0.0881. All right, lovely. Now let's move on to part C. Determine the probability that fewer than 7 people will pass this polygraph test. Let's highlight the idea of fewer than 7 people, and actually, yeah, will pass. Right. So if we write that down here, all right, so this question is asking us to find when the probability of x is less than 7. So you'll notice that on my little calculator here, if when I go less than, I have to add in the equal sign here, okay? So in order to calculate that, I'm going to have to say because we've got discrete data here, all right, so one person counts for one person, we can't have half a person. This probability is going to be the same as x being less than or equal to 6. And funnily enough, it's the same number from last time, so I've actually got that over here. And that turns out to be 0.121, rounded to 3 significant figures. Let's put that in 0.121. Okay, and so that is the answer to question 5. I will stress that if you don't know how to find these out with your calculator, to research that yourself, because every calculator is a little bit different, and your calculator will be able to do most of the heavy lifting in this question for you. Okay, so let's move on. Question 6. The graphs of y equals 6 minus x and y equals 1.5x squared minus 2.5x plus 3 intersect at 2, 4 and -1, 7, as shown in the following diagrams. In diagram 1, the region enclosed by the lines y equals 6 minus x equals -1, and x equals 2, and the x-axis has been shaded. All right, cool. And part A asks us to calculate the area of the shaded region. All right, so let's go through, underline, highlight important information. So the two graphs, we'll want to consider the points of intersection. Cool, I'm going to redo that one. And this bit down here, right? Let's take this. All right, cool. So there's two ways we could go about calculating the area of the shaded region here. We could find, so one method would be to find the definite integral of y equals 6 minus x between x is equal to 2 and x is equal to -1. That would be absolutely fine, and you can use your calculator to calculate that. So alternatively, what we could do is just identify the shape that is made by the shaded region, which is a trapezoid or trapezium. Either name is fine, they mean the same thing. Where we've got sort of on this longer side, we go from the x-axis, beg your pardon, when y is equal to 0, all the way to when y is equal to 7. So that means the length of this side is 7. The length of the other parallel side is, once again, we're going from x-axis, so y is equal to 0, up to y is equal to 4. So that has a length of 4. And then the height, or the other side, is 3. All right, so that's 3 there. Now, I understand why you might be confused why I'm calling that the height. Is essentially we could turn it over like that, and then that would be our trapezium trapezoid, if we wanted to look at it like that. And so we'll leave that there, and let's go down. Let's show our working. So the formula for the area of a trapezoid is in your formula booklet, which is as follows. A, the area, is equal to a half multiplied by A plus B multiplied by the height. Okay, where A and B are the two parallel sides. Okay, so if we go up here, we can see the two parallel sides are this. There's the 7 and the side which has 7, a length of 7, and the side that has a length of 4. All right, so let's go down. Let's plug this into our formula. In fact, let's even say up here we'll go A is equal to 7. We've got B is equal to 4, and we've got H is equal to 3. Cool. And so we'll bung this all into the formula, 7 plus 4, and then multiplied by 3. And if we go, in fact, so properly, so we'll go 0.5 times by 7 plus 4, which is 11, times by 3 equals, and we get an answer of 16.5. All right. Now, I'd always recommend writing units squared on the end here if you're not given a specific unit. Just to show the marker that you realize that it's an area. All right. Okay, let's move on to part B. what have we got? In diagram 2, the region enclosed by the curve y equals 1.5 x squared minus 2.5 x plus 3, and the lines x equals -1 and x equals 2, and the x-axis has been shaded. Right, okay. Part B1, or I, write down an integral for the area of the shaded region in diagram 2. Okay, so that's the area between the x-axis and our curve 1.5x squared minus 2.5x plus 3, and then between these lines here, x equals -1 and x equals 2. Right, so the definite integral that we're going to have to write for this is the integral sign, so like that, okay, from x is equal to 2 to x is equal to -1, and then we'll put our function in our graph, which is 1.5 x squared plus 2.5 x plus 3. I believe that's meant to be minus 2.5 x, right? Yeah, beg your pardon. And that is, and then dx on the end, integrating with respect to x. And then, yeah, that would be our answer for part part B1. And then moving on to part B2 or part BII, let's go. And it says calculate the area of this region. Let's go through and we'll do our highlighting. Okay, write down an integral for the area of the shaded region. There we go, we'll do that. All right, and so the best way to do this for this AI SL exam would be to do this in your calculator. You can do it by hand, and I would recommend knowing how to do it by hand, just in case you have like a show that question in your exam, though this question doesn't require you to show any working or show how you find the answer. So I would recommend knowing how to do it in your calculator. So here I have this app here where I can pull up I need to get rid of all that. Pull up a definite integral, okay, from x is equal to 2 to x is equal to -1. Nice, and then our function is as follows: minus 2.5x plus 3. All right, cool. Just double check that you put everything in correctly, and then you push go. And then there we have an answer, okay, 9.749985, which we would round to 3 significant figures, which would be 9.75. All right, so what I'm going to do is, in fact, we'll just get rid of this. We'll say area equals 9.75 units squared. All right, cool. So there is the answer to part B. All right, moving on to part C. Hence, determine the area enclosed between y is equal to 6 minus x and y is equal to 1.5 x squared minus 2.5 x plus 3. Okay, so let's say area enclosed between this guy and this guy. All right, so the way we can think about this is we're trying to find this area here, right? Okay, so the best way to calculate this is to take our area that we found in part A, which is all of this. Okay, and then we're going to subtract essentially what we just found, which is this area down here. All right, so that's, yeah, that would be the easiest way. And then we would be left with the area enclosed by the two graphs. So let's go do that. And so C, the area is, in fact, let's just say area is equal to trapezium. That's I'll write that a bit nicer. Or we'll say trapezoid, right? Because that's how IB call it. That's what IB calls these shapes. So trapezoid area, subtract part BI area, I'll say. Part BII area. And in fact, how about we change trapezoid area to being just part A area? Cool, let's write that in part A area. Sweet, and then that would give us our answer. So let's bring this down. We'll go A is equal to 16.5 subtract 9.75, and we will find that to be equal to 6.75. Units squared. All right, cool. And so that is the answer to part 6. Sorry, question 6. Question 7. A college runs a mathematics course in the evening. Scores for a test from this class are shown below. For these data, the lower quartile is 62 and the upper quartile is 88. And part A asks us to show that the test score of 25 would not be considered an outlier. Okay, so it is somewhat generous that they've given us the lower quartile and upper quartile here. If they hadn't, we'd have to find it out ourselves, which I would recommend definitely knowing how to do. So let's highlight this generous information that we're given. And we'll label it as Q1 for lower quartile, which is equal to 62, and Q3 for the upper quartile, which is 88. All right, and so we have to show that 25 is not an outlier, or the score of 25 would not be considered an outlier. Now, the rule or formula for outliers is not given to you in your formula booklet, so you will have to remember this off by heart. And here is an easy expression that you can remember for the acceptable range, or the accepted range of values, so values that would not be considered outliers, and then any value outside of this range would be considered an outlier. And it is as follows: Q1 minus 1.5 times the interquartile range, IQR. All right, and then so we'll write accepted range here. All right. Cool. And then the upper limit is the upper quartile, Q3, plus 1.5 IQR, which is the interquartile range. Now, the formula to find the interquartile range is in your formula booklet, so I'll write that down here. So IQR is equal to Q3 subtract Q1. All right, and so then, yeah, now we can go about and sort of answer our question, okay? We'll write down our info here. We've got Q3 is equal to 88, and Q1 was equal to 62. Now, intuitively, we can assume that 25 is going to be from this lower limit. So we're going to have to show that 25 is more than this expression here. Therefore, it would be within this accepted range. Okay, so we need to show that 25 sits within the accepted range. We don't really have to worry about this up a bit, because it's definitely going to be, that number here is going to be more than 88. And so we don't really have to worry about that so much. Okay, so over here. So therefore, what we need to do is say 25 is more than Q1 minus 1.5 times the interquartile range. Now that is 25 is more than 62, which is Q1, minus 1.5 multiplied by 88, subtract 62, and we'll bring this over here. In fact, now we'll do it down here. And so we'll bring our calculator over, and we'll find 62 subtract 1.5 times by brackets 88 subtract 62, and go. And that gives us 23. All right, cool. So we can say 25 is more than 23. And so we will conclude, and we'll use these 3 dots again, which means therefore 25 is not an outlier. Cool. All right, so there is the answer to part A. Once again, I'll stress remembering this off by heart, or notably just the lower limit and the upper limit for an outlier. Okay. And yeah, this formula here for the interquartile range, that is in your formula booklet, but it would be worth memorizing and knowing off by heart. Okay, let's move on to part B. All right, what have we got? The box and whisker diagram showing these scores is given below. All right, and so okay, so there that is from this box and whisker diagram is from this data set up here. All right, so that's cool. Another mathematics class is run by the college during the evening. A box and whisker diagram showing the scores from this class for the same test is given below. Right, a researcher reviews the box and whisker diagrams and believes that the evening class performed better than the morning class. With reference to the box and whisker diagrams, state one aspect that may support the researcher's opinion and one aspect that may counter it. Okay, so we'll look at it from, so we've got to have one aspect that may support the claim, all right, and one aspect that will counter it. All right, so let's go up to the box and whisker diagrams and sort of visually have a look. And we'll start with the idea of finding something that supports his claim, right? So the one that jumps out to me anyway is the median mark. Okay, so the median mark in the evening class is higher than the median mark in the morning class, right? And so that would be our one aspect that supports his claim. I suppose there would be other things you could probably point out, but that's the most obvious there. Is there anything else really that points out what's the upper quartile looking like? They're the same, and the maximum mark is the same. So actually, I will take that back. That looks like the only part that supports the researcher's claim. And if we look at it from the standpoint of considering what counters his claim, we actually have a handful of aspects that counter his claim. We are only asked to name one, so we could go as far as to say that the lowest mark for the morning class is higher than the lowest mark in the evening class. You could say that the lower quartile in the morning class is higher than the lower quartile in the evening class. And you probably find a lot. We only need to say one. So I'm going to go with the lowest mark and the median. All right. So here is, so I'll say the median mark in the evening class is higher than the morning class. Oopsie. Morning class. Okay, so there is our one aspect that supports the researcher's claim, and then now the one aspect that that I'm going to use is that the lowest mark in the morning class is higher than the lowest mark in the evening class. Okay, so let's say, and so here the lowest mark in the evening class is lower than the lowest mark in the evening class, morning class, paper. And what I would also recommend potentially here is to make the life easy for the marker. What I'm going to do is just label both of our claims here. Let's see if I can do this. What we will do is we'll just take all of this, bring it down one. I'm going to move my B up, back up to here, and so I'm just going to write support here, and then and we'll go there, yeah, support, and then counter here. And then that kind of, quite clearly gives the marker, what you're talking about. So that would be good. Now, what I'm also going to do to wrap up this video is I'm going to bring you over what the mark scheme says. So, because if you notice something else, then especially to counter his claim, there's plenty of options. So here, this is what the mark scheme for this exam says about this question. Here we go. Bring this. There we go. Right. Yep. All right. So this is what the mark scheme says. So we've got. So yeah, the median class is that's the median score. Median mark, okay, is in the even class is higher. So that's the only one we said. Then we've got all these options here. So scores are more spread out in the even class. Scores are more inconsistent, right? Lower scores in the even class. Okay, interquartile range is lower in the morning class, or the lower quartile is lower in the even class, right? So you had a handful of aspects that could counter this researcher's claim. I'm going to put full stop on the end there, eh? Okay, cool. Yeah, that is the answer to question 7. Yeah. Question 8. A study was conducted to investigate whether the mean reaction time of drivers who are talking on mobile phones is the same as the mean reaction time of drivers who are talking to passengers in the vehicle. 2 independent groups were randomly selected for the study. To gather data, each driver was put in a car simulator and asked to either talk on a mobile phone or talk to a passenger. Each driver was instructed to apply the brakes as soon as they saw a red light appear in front of the car. The reaction times of the drivers in seconds were recorded as shown in the following table. Right. Yeah. At the 10% level of significance, a t-test was used to compare the mean reaction times of the 2 groups. Each dataset is assumed to be normally distributed, and the population variances are assumed to be the same. Let mu1 and mu2 be the population means for the 2 groups. The null hypothesis for this test is HO is mu1 minus mu2 is equal to 0. Right. Part A asks us to state the alternative hypothesis. So with the alternative hypothesis, there are 3 options. We have the means in this case not being the same, one mean being higher than the other, and vice versa, the other mean being higher than the other, or less than. Okay, to figure out which one we need here, we need to go back up to the top, the first paragraph here, and we see it says, study was conducted, ... mean reaction time of drivers who are talking on mobile phones is the same. Okay, so I know it's obviously a very small word, but that's critical. That's a critical bit of information in order to answer part A, to state the alternative hypothesis. Now, this could say the other options here could be whether the mean reaction time of drivers who are talking on mobile phones is less than the reaction time or more than, and then that would give us a different alternative hypothesis. Okay, so all this is asking is so we're trying to find out whether they're the same. So regardless of whether one's less or more than the other, doesn't matter. Just we want to show whether they are the same or they're not the same at this 10% level of significance. So alternative hypothesis, we'll highlight that. And so that will be, so since all we need to do is basically show that they are, so if our null hypothesis is that they are the same, all right, then our alternative hypothesis is going to be that they're not the same. And the way we denote that is we write an H1 and we'll say mu1 minus mu2 does not equal 0. Okay, so there is the answer to part A. Let's move on to part B. Calculate the p-value for this test. Right, let's say p-value. Now, your calculator is going to do the heavy lifting in this question. So you're going to need to know how to use the statistics section or mode in your calculator, how to make two lists in your calculator, and then specifically for this question, you'll need to know how to run a two-sample t-test in your specific calculator. I'll bring you over to the one I have, which is on my laptop, which is an emulator of the Casio FXCG500. Yeah, so they're all slightly different. More or less, the process will somewhat be the same. But yeah, I would advise if your calculator is different to my one, just Google at YouTube how to run this test, and it'll be pretty clear. Okay, so I've already gone in and put in the data from the table here. So we had 7 lots of data. This list 1 here is for talking on the mobile phone, and list 2 is for talking to a passenger. All right, so with this calculator, the way I do it is I'm going to go to the calculation section, then go to test, right, and then I get this down here. All right, I need to run a two-sample t-test, so I'm going to click that, go next, right? So mu1 condition, so this is effectively what's the alternative hypothesis, all right, and our one is not equal, okay? So you've got these, less than or greater than. We're not equal. And for the AI SL course, you'll always have this pooled part on, okay? So always have that on if you're doing AI SL. Yeah, all right, so now we go next. And here we have all our different, so we've got the mean for the first group or the first list, which is talking on a mobile phone at 0.85. The mean here, standard deviation, a whole bunch of different statistical measures, okay? But the one thing that we are interested in is this one here, okay? This is our p-value, all right, probability. Okay, so what's that? 0.0778 to 3 significant figures. So let's come back to the pad, and we will write that down. Let's see. There we go. All right, we're back. So, and it was part 1, right? No, just B by itself. Okay, so p-value is equal to 0.0778. Right, and so there is the answer to part B. Let's move on to part C now. And there's 2 parts to this. So we've got part 1. State the conclusion of the test and justify your answer. Okay, so the way we're going to state the conclusion here, so we're going to say let's say here, our p-value of 0.0078 is less than our significance level, which I'm just going to write as SL, okay, which is equal to 0.1 or 0.10 if you want to write as 10%, but yeah, 0.1 would be fine, okay? And so in this case, all right, so when the p-value is less than the significance level, right, we reject the null hypothesis, right? Very good to sort of, write this down, remember it, have it on a cue card, and just practice before your test to remember which way they go. Okay, so if p-value is less than the significance level, we reject the null hypothesis, and vice versa. All right, so then we'd say, I'm going to put these 3 dots here that I've talked about a couple of times, means therefore in mathy language, okay? And we'll say, we reject HO. Okay, and so that will be the answer to part CI or part C1. Now let's move on to part 2 and let's see what that asks. So what do we have to say? State what your conclusion means in context. All right, this is going to be in the context of the question here, which is talking about the reaction times of the drivers, whether they have a passenger or they're talking on the phone. All right. And since we're rejecting the null hypothesis, which is stating that the means are equal to each other, that means our conclusion is that the means are not equal to each other. And so a bit of a standard way to start these off is if you say there is sufficient evidence to suggest that, what should we say, the mean reaction times are different. And then we have the answer to question 8. I will stress, if you are unsure of how to do part B here, so calculate the p-value and use your calculator to that, do just Google it, YouTube, or find out how to do that with your calculator. It'll be quite important for your exam. There'll definitely be a question along these lines. But yeah, and the good thing is your calculator does most of the heavy lifting, which is quite nice. Anyway, there we go. Quick answer to question 8. Question 9. The graph below shows the average savings $1,000 of a group of university graduates as a function of T, the number of years after graduating from university. Part A asks, write down one feature of this graph which suggests a cubic function might be appropriate to model this scenario. Okay, so we have a few features that we could use to suggest that this is a cubic function. We only need to state one, though. I'll tell you the 3. So the first one, most obvious, will be perhaps that there are 2 turning points. There is a maximum and a minimum. Additionally, so another feature would be that there are 3 x-intercepts. That's typical of a cubic function. And lastly, there is only one point of inflection, which would be roughly around here. Okay, so any one of those features would be adequate to answer part A. You only have to use one, so I'm going to go with the turning point idea. So I'll just write down here. We'll say there are 2 turning points. We'll say a maximum and a minimum. Okay, and then, yeah, to state again, you could also say that there are 3 x-intercepts or that there is 1 point of inflection. And those would be adequate as well. But let's move on to part B. So the equation of the model can be expressed in the form S is equal to AT cubed plus BT squared plus CT plus D, where A, B, C, and D are real constants. Okay, let's highlight that because we'll definitely need that. The graph of the model must pass through the following 4 points. All right, so from this table. Part B1 asks us to find the value of D. All right, now when we look at our function here, okay, D is effectively representing the y-intercept here, okay? Because if T is equal to 0, effectively this AT cubed bit is going to be equal to 0, so there's nothing there. The BT squared bit is going to be equal to 0, so there's nothing there. CT is also going to be equal to 0. So we'd just be left with D, okay? And yeah, so that's when T is equal to 0, S is going to be equal to 2D, effectively. And we get that from the first line here, okay? We have that here, okay? So when T is equal to 0, S is equal to -5, and from what we just saw, right, that means the A bit, the B bit, the C bit, they're all just going to equal 0. And we're going to get 0 plus 0 plus 0 plus D is equal to -5. And so therefore the value of D is going to be -5. So if I sort of write that out down here, okay, we'll have B. If we said, S, let's say, and we'll write in sub T is equal to 0 and S is equal to -5, all right, from this first bit of the table, okay, and we'll do that. We'll say S is -5 is equal to A multiplied by 0 cubed, which is just 0, plus B times 0 squared, which is also going to be 0, plus C times 0, which is 0, and then plus D. Okay, and so therefore we get D is equal to -5. Okay, and so there is the answer to part BI. So I should probably bring this over and we'll put part I or part 1 in there. All right, let's move on to part 2. Hence, write down 3 simultaneous equations for A, B, and C. Okay, so that's going to be using these next 3 sort of values we're given here. Okay, so if we substitute in T is equal to 1 into this, into our equation or our model for S, we'll get sort of A multiplied by 1 cubed, which is just A, plus B times 1 squared, which is just going to be 1 again, so it's going to be B, plus C times 1, which is C, plus D, and we have that equaling to 3. All right, so that could be our first one. And then subsequently, we're going to go through this. We're going to substitute 2 in for T in each part here, and then get a different coefficient for A, B, and C, and that's going to equal -1. And then we're going to substitute in T is equal to 3 into our model, right? And then we're going to get then again a different coefficient for A, B, and C, and then that is going to equal -5. All right, let's go do that. And here we'll say the 3 simultaneous equations for A, B, and C. Yeah, cool. All right, so so our first one is when T is equal to 1, S is equal to, now I've gone 3. All right, and so then we also have, so we'll write that in here. We've got 3 is equal to A times by 1 cubed, so A multiplied by 1 cubed, plus B times by 1 squared, plus C times by 1 plus D, which we know is -5, so we can just put that in, -5. So therefore, we're going to have 3 is equal to A plus B plus C -5. All right, so there's our first equation. And then now when we move on, we're going to say when T is equal to, was it 2? And S will be equal to, we got -1. Okay, so now we can go through and do that. We'll say -1 is going to be equal to A multiplied by 2 cubed plus B multiplied by 2 squared plus C multiplied by 2 -5. Now, if we work through this, we're going to get A multiplied by 2 cubed, which will give us 8A. Let me clean that up. That's not very good. And then moving on, we're going to get B multiplied by 2 squared, which is going to be 4B. And then lastly, we're going to get 2C -5. All right, so there is our second one. So let's just, we'll label these. This is our first equation. This is our second equation. Am I going to run out of room? Most likely. We can add a new page there. That's right. And then now let's find our third one. Okay, so this is going to be when t is equal to 3 and s is equal to -5. All right, so let's bring that down. And I'm just going to be somewhat lazy and use this. Is that going to work for me? Yeah, there we go. When t is equal to 3, s is equal to -5. Okay, and so we'll go -5 is equal to a multiplied by 3 cubed plus b multiplied by 3 squared plus c multiplied by 3 minus 5. And now if we clean this up, we're going to get 3 cubed is 27. So we'll get 27a. 3 squared is 9. So we're going to get 9b plus 9b. Then plus 3c minus 5. And that is our third. Okay, so there is the answer to part B2. Let's move on to part 3. And so we are asked to hence or otherwise find the values of A, B, and C. Now, the best way to do this is to use your GDC, your graphics display calculator, to solve these simultaneous equations. If you are unsure of how to do that in your specific or particular calculator, give it a Google, research. Just Google the model of your GDC, the calculator that you have, and then followed by systems of linear equations or how to solve simultaneous equations with 3 variables as well. I have to write that in, and there should be a YouTube tutorial or a little manual that will run you through how to do it with your specific model. However, I have this calculator here, Symbolab, which can do systems of linear equations for me. I will also mention otherwise you can use matrices to solve this, though matrices aren't involved in the AISL course. So yeah, the best way would be to learn how to do this. So learn how to do this in your particular calculator. So let's go into split view for this, so it's not so small. And we'll put in our 3 equations, and it'll spit out a value for A, B, and C. I will also stress, or I will just note that for each of these 3 equations, you could have also brought the -5 to the other side of the equation. So for example, equation 1 would have been 8 equals 8 plus b plus c. Equation 2 would have been 4 equals 8a plus 4b plus 2c, and equation 3 would have been, what have we got? 0 equals 27a plus 9b plus 3c. Both would have been fine. So let's go without further ado. Let's plug these in. So we've got 3 is equal to a plus b plus c. Right, separate these out with a comma, and then we have -1 is equal to 8a plus, what have we got, 4b plus 2c. I've got to put in the -5, both of these. -5, and that comma in, -5, right, and then again, space, -5 is equal to 27a plus 9b, 9b plus 3c -5. Right, now I'll click go, and that gives me the 3 values, weirdly in the order of A, C, and MB. Slightly odd, but anyway, that's the way that my calculator does it. Yeah, once again, if you are unsure of how to input that into your own specific calculator, then just give it a look, and your calculator should be able to do it. It will definitely be able to do it if it's a GDC available for these, or allowed for these exams. Okay, so let's put that in. What do we have? A is equal to 2, B is equal to -12, and C is equal to 18. Okay, slide over. Okay, part BII, or III, sorry, I should say. A is equal to 2, B is equal to -12, and C is equal to 18. Okay, lovely. Let's move on to part C. Right, so now we have to, a negative value of S indicates that a graduate is expected to be in debt. Okay, use the model to determine the total length of time in years for which a graduate is expected to be in debt after graduating from university. Okay, so if we go back up to our graph here, essentially what this question is asking us to find is the total amount of time that this graph is below the x-axis, or the t-axis, if you will. Okay, so that is essentially, that's this time here. So how long is that time there? And then also how long is this time here? All that there. Okay, and so the way we're going to find that is by, first of all, finding the x-intercepts for our function. Okay, and then we're going to take this x-intercept, and so say take that and then add in the time which is from here to here. Okay, so there's a bit of maths involved, but we will also have to graph this function in our calculators. You don't have to, but that would be the most efficient way. So let's go and do that. So let's we'll bring our calculator back over, and I'll go into split view again. Right, and so now I'm going to change the variables of S into Y, and then T into X, just so that the calculator recognizes that I want it to graph on a Y and X axis, or XY axis. And so yeah, let's do that. So we got Y is equal to, A was 2, so it's 2x. I need to select that one, cubed, and then we've got subtract 12x squared, all right, plus 18x, and then it was subtract 5. Okay, so there is our cubic function. Click go. Okay, and so now that has given me this function down here, and I can go here and say find the x-intercepts, and there I have them. All right, so that's helpful there. So I've got the first one is at 0.35821. So coming back up to here, that's this one here. Oh, that's this one here. Okay, and then the next one, which is 1.83174, which is that one. And then the last one is 3.81003, which is there. Okay, and so the time in which S is negative, or below the x-axis, is up to this first x-intercept, and then between these two. All right, so let's just get rid of that. Let's write down these x-intercepts, and we'll just maybe go to there. All right, cool. So C, x-intercepts, we'll say x-ints, 0.35821 ... comma 0, and then the next one was, in fact, let's bring this over here. Next one is 1.83174, comma 0, and then the last one we'll write down here, 3.81. 1003 ... comma 0. Okay, and then have I added ... to that one? No, I haven't. We will add an ... to that. And essentially what that means is that this number is completely unrounded. This number here is just written to the 5th decimal point. And the reason why I'm writing it to the 5th decimal point is just to be overly sure, overly accurate of my final answer. Okay, so there are x-intercepts. All right, cool. So we don't need the calculator anymore. And we know that it's from essentially from 0, from t is equal to 0 up to that first one. All right. So s is below 0 for 0.35821 years, and then plus the time in which s is below 0, or which is between these two x-intercepts. All right, and the way we can sort of find that out is go brackets 3.81003 subtract 1.83174. All right, and then now we can, let's put that into here, and so let's go 0.3. Is it going to put in a point for me? There we go. 35821 plus the brackets 3.1003 subtract 1.83174 close bracket equals, and that gives me an answer of 2.3365 years. And so in conclusion, we'll round that to 3 significant figures. So therefore, S is below 0, aka they are in debt. The student is in debt for 2.34 years. 2.34 years. Cool. And there is the answer to part C. Question 10. The masses of Fuji apples are normally distributed with a mean of 163 grams and a standard deviation of 6.83 grams. When Fuji apples are picked, they are classified as small, medium, large, or extra large, depending on their mass. Large apples have a mass of between 172 grams and 183 grams. Part A asks, determine the probability that a Fuji apple selected at random will be a large apple. Okay, so our important info is that they are normally distributed, the masses, all right, with a mean of 163 and a standard deviation of 6.83 grams, all right? And large apples have a mass of between 172 and 183 grams. And we want to find the probability that a randomly selected apple is a large apple. Okay, so the way we denote a normally distributed variable or a normal distribution is so a standard letter to use is n. You don't have to do it, but we go x, squiggly line n to represent it's normally distributed. And then followed in brackets, we put the mean, which is mu, and then followed by sigma squared, which is the variance, right? If we apply that to our case here, how about we use the letter m for the masses? You can use any letter you like. And then the mean was 163. And the variance would be 6.83 squared, right? Okay, and so we have to find the probability that m is between 172 and 183. All right, so a good way to, a bit of a hint for these questions is to draw yourself a little sketch of a normal distribution of a bell curve, so you can visually see the probability that you're trying to find. So here I've got this one. It's not perfect, but it doesn't have to be even in your exam. It doesn't have to be just a quick little one, and a couple vertical lines to visualize the probability that we're trying to find. So for this one, we are trying to find roughly the probability that a randomly selected apple falls between this range here, okay? Where this lower number would be 172 and this higher number would be 183, okay? And so once again, your calculator is going to do the majority of the heavy lifting here, all right? And so I will show you how to do it on the FX CG500 calculator. Though if, your calculator is different, I urge you to just give it a little Google search or YouTube search of how do I do a normal distribution in your specific model of GDC. And there should be, there'll be plenty of tutorials up there. Okay, so for this one, we go to the statistics section. And I'm sure there's other ways to do it, but this is how I do it. And then I go to calc and then distribution. Right, then I go to normal CD and then bring this down. Our lower bound was 172 grams. Our upper bound was 183. The standard deviation was 6.83 and the mean was 163 grams. Then I push next, and there I have the probability that an apple ranges between these two weights, 172 and 183 grams, and that is 0.0921. All right, so let's bring you back to rounded to 3 significant figures, so I should say. Let's bring you back to the pad. Okay, lovely jubbly. So here we'll put in 0.0921. Okay, and so that is the answer to part A. All right, let's move on to part B. So where am I going? I'll start that down here. Approximately 68% of Fuji apples have a mass within the medium size category, which is between K and 172 grams. All right, and we're asked to find the value of K. So 68% of Fuji apples have a weight between K and 172. Right, we're asked to find the value of K. So here, if we represent this or if we write down the probability that we're trying to find, what we've got given in the question here is we're told that the probability of a randomly selected apple being between K and 172 grams is equal to 0.68, okay? And so if we once again bring in our normal distribution curve and have a look at this visually, so we'll say 172 is roughly this line here, and we'll say, let's say K is going to sit around here, let's say, all right? And so K, 172 here. And we are asked to find, we are told that this area in here is equal to 0.68. Now, when I say the area, that is the probability that the mass sits between these two values, and the total area under the normal distribution curve is equal to 1, okay? And then also, what should be useful to know is that if you go to the left of the mean, all right, so anywhere this way, that represents 0.5 or a probability of 0.5 or the area of 0.5, and same as if you were to go to the right. So if you just go this way of the mean, all those values will be, or the probability of getting any of those values is 0.5 or 50%. Now, so we need to find, obviously, the value of K, and there are a number of ways you can go about this. Though what I think will be the best way is if we were to find the area to the left of 172, okay? So all of this, let's zoom in, all of this, okay? And we find that value, okay? And then we substitute 0.68, which is this middle area. We would be left with this. That's what we would be left with. And then that would give us the probability of an apple being less than K, okay? And so then from there, that will help us find K. So if I write what I've just tried to sketch out, I apologize for that not being overly neat, but if we're trying to try and find the probability that a randomly selected apple is less than K, what we can do is say this is going to be equal to the possible probability that a randomly selected apple is less than 172 grams, subtract 0.68, okay? And so then to just show that, and how about we do this? We'll take this. I'll take this back, but just so I can show that, we're going to find this area here. All right, and then subtract our middle area, 0.68, and then that will leave us with the probability that a randomly selected apple is less than K grams, okay? So let's go back, put that back up there. All right, cool. Now so we're going to go back to our calculator, and we're going to find out the probability that a randomly selected apple is less than 172 grams. All right. And so let's go. Okay, I'll do this again. So with this one, we go to the statistics section, or I do. There will be other ways to do this. Then go to distribution. I want normal CD, and I want to find the probability that a randomly selected apple is less than 172. I'm going to use the lower bound of 0, upper bound of 172, standard deviation of 6.83, and the mean being 163 grams. Okay, and so that gives me a probability of 0.9062. We'll just go to the four decimal places, so 9062. Okay, so let's come back to the pad and we'll put that in. It's going to pop up any second. Nice. So the probability of this being less than K is equal to what we just found for this one. So that was 0.9062. Subtract 0.68. And if we do that, we'll bring this over. What's it? 0.9062 subtract 0.68. Go. So 0.2262. All right, so 0.2262. All right, so now I know the probability that a randomly selected apple is less than K grams. So if we were to denote that with we have now just found that if we bring here, we'll say this is K, we have found that this area under here is 0.2262. Okay, and then so now with this bit of information, we can go back to our calculator and use the inverse normal function, which will then give us the value of K. Right, and so I'm going to bring you back to the calculator and show you how we do that. Okay, so we'll back it up from here. In fact, we'll start again. So statistics, calc, distribution, oh, no, beg your pardon, statistics, calc, and then this time we're going to need to go to inverse distribution, okay? So inverse distribution, inverse normal CD, so that's correct, we've got that all in there. Okay, and so then here, so this tail setting, if you remember back from what we had in the pad, we need to find the range or the value, or our tail setting needs to be to the left, okay, because we've found the probability that a randomly selected apple is less than k grams, all right? We have to change this to left. The probability that we found was 0.2262. That was right, yeah. Our standard deviation is 6.83, and our mean was 163. Okay, we click go, and here we have 157.8678 grams for K. And so rounded to 3 significant figures, we would get 158 grams. So let's come back to the pad and we will put that in. Cool. And so we'll put therefore K is equal to 158 grams. And there is the answer to part 10. Question 11. Consider the function fx is equal to x squared minus 3 over x, where x can't equal 0. And part A asks us to find f dash x, or the first derivative of fx. Okay, so for this, you're going to need to know how to differentiate a function. And actually, specifically for this one, you're going to need to know some of your indices laws. Okay, so specifically, how can we rewrite 3 over x so that it's easier to differentiate? All right, now the way we're going to do that, okay, is write fx is equal to x squared minus 3x to the power of -1. Okay, so the indice law that I use there is essentially when you raise any number to the power of, let's say if we go 2 to the power of -1, this is equal to 1/2. All right. Equally, if we had, let's say, 2 to the power of -2, that's equal to 1/2 squared, which is equal to 1/4. All right. So whenever you raise a power to, a number to a negative power, it's essentially moving it to the denominator. All right. So I've done the reverse here. I've taken the x from the denominator, lobbed it up to the top, to the numerator, or to the top line, and I've just represented it as to the power of -1, right? And so now I can quite easily apply our differentiation rules. Now this is in your formula booklet, how to differentiate. So I'll write that here. If we have fx is equal to, let's say, ax to the power of n, okay, then the first derivative of this function here, okay, is going to be equal to, we bring the power, so n, to the front of the equation and multiply that by the coefficient, which in this example is a. So we're going to get n multiplied by a, right? Then x, and then we have to subtract 1 off the power. Okay, so you can kind of think of it as 2 steps. You bring the power to the front and multiplying the coefficient by that power, right? So that's the first step. And then the second step is to remember to subtract 1 off of the power. Okay, so if I apply that to our original function here, we have got, and so I should note that you do this to every term along the function. Okay, so this, the function could be lots of terms, a long polynomial, and you apply this rule to each term of the function. All right, so for this one, I'm going to bring the 2, the square, the power of 2, to the front and multiply that by the coefficient of x, which in this example is just 1. You don't usually write a 1 there, but the coefficient of x is 1. So we're going to get 2x, and then I have to subtract 1 off of the power. Okay, this is another example where we don't write x to the power of 1, we just write x, and that means it's to the power of 1. Okay, so x squared, when we differentiate x squared, that becomes 2x. All right, and then now we move on to the next one. All right, so we're going to get, let's do everything. So we're going to go minus, and then now this is going to be, have to bring the -1 to the power to the front, all right? And that's going to have to multiply 3x, and then we're going to have to go -1 minus 1, okay? So we still have to subtract 1 off the power. And if we clean this up, let's write that back in, we're going to get 2x, okay, plus 3, and then 3x to the power of -2, okay, which we could write if we wanted to follow the format in the question, we can say 2x plus 3 over x squared. All right, and so there is the answer to part A. So part B says line L is a tangent to fx at the point 1, -2. Use your answer to part A to find the gradient of L. Okay, so another term you can use for the first derivative is, you can call it the gradient function. Okay, it's quite a good thing to remember, the link between a function and its first derivative. Okay, so basically what the first derivative does is it will tell you the gradient of that function at any particular x value that you substitute into the first derivative. Okay, so for this question here, we're told that we need to find the gradient of L. Okay, and we know that L is a tangent to the curve at this point here, where x is equal to 1, and obviously y is equal to -2, but that's not so important at the moment, just when x is equal to 1. All right, so then to answer this, what we need to do is sub x is equal to 1 into f dash x, or our first derivative. All right, and that will look a little bit like this. So we'll go f dash x, sorry, we should put 1 in there, is equal to 2 times by 1 plus 3 divided by 1 squared, which is just 1. And so that's 2 plus 3, which is equal to 5. Okay, and so now we can conclude that the gradient of our line L is going to be, what have I done? Is going to be equal to 5. All right, and there is the answer to part B. Okay, cool. And so moving on to part C, we are asked to determine the number of lines parallel to L that are tangent to fx, and justify your answer. Okay, so this one's definitely a step up from the other two, right? So essentially, what this question is asking us is to find how many possible values of x are there for which you sub into f dash x, or our first derivative, and then that equals 5. So that was a bit of a roundabout way of saying it, but yeah, we need to find the possible values of x where find x values for f dash x is equal to 5. And essentially this is saying how many times does our function here have a gradient of 5, okay, but not including the line L. Okay, so we just need to find how many lines that would be, the number of lines that would be parallel to L, aka have the same gradient of 5. Okay, so the best way to do this is to graph these on our calculator. Okay, and I'm going to bring you over to a online I'm going to bring you over to Desmos, so you can hopefully see everything a little bit better, visually see it. Yeah. Okay, so here is Desmos. It's a graphing calculator. Now I'm going to write in our first, so just fx. Okay, so fx was equal to x squared minus 3 over x. All right, and so there is our original function fx, all right? Then our first derivative that we calculated, okay, is 2x minus 3 over x squared. Right, and then now it'll be hard to see, but here this represents, sorry, I beg your pardon, that should be plus 3 over x squared, plus 3 over x squared. And so here, what you can see with our blue line, the blue line is representing the gradient of the red line. So the easiest bit to see here is that at this point here, this minimum, that is when the gradient of our red line is equal to 0. Okay, and that is represented by the blue line here crossing the x-axis, so being equal to 0. You can see how their x values are the same. All right, so that's a good way to visualize that the first derivative is the gradient function and gives you the gradient of the original function, if you will. Okay, and so we're asked to find essentially when our first derivative, so f dash x, the blue line, is equal to 5. Now, the easiest way to do this, I'm going to get rid of our original function, okay, because we don't need that anymore. We're just going to put y, and put a horizontal line at y is equal to 5, okay? And here we can see each time our first derivative is equal to 5, or the gradient of our original function, fx, has a gradient of 5. And this one here, this 1, 5, this is representing the when you're representing the line L, which is tangent at when x is equal to 1 and then y is equal to -2. If we, I know that says there, it's y equals to 5. Let me bring back in, let's bring back in our original one as well. And so you can see that. Okay, so here you can see this is 1, 5, all right? And then if we look at now it's the purple line I see, but at 1, 2, 1, -2, sorry. So that's that point there, okay? And so line L is tangent here and has a gradient of 5, all right? Let's get rid of our original function now, so we don't really need that. And so to answer part C, there are 2 other points of the graph fx, which are parallel to the line L. All right, so we've got 2 points here. And so that is the answer. Let's bring you back over to pad. And so we will conclude that there are, so let's go into green. So f dash x equals 5 has 3 solutions. And so therefore, there are 2 lines. We'll just say 2 lines. That is the answer. Okay, so not including line L. So 2 lines are parallel to line L. And there is the answer to question 11. Question 12. The cross-section of an arched entrance into the ballroom of a hotel is in the shape of a parabola. This cross-section can be modeled by part of the graph y equals -1.6 x squared plus 4.48 x, where y is the height of the archway in meters at a horizontal distance x meters from the point O in the bottom corner of the archway. Okay. Part A asks us to determine an equation for the axis of symmetry of the parabola that models the archway. All right, so let's highlight our model function. Okay, so there we go, and we're being asked to find the axis of symmetry. Now, effectively, the axis of symmetry is the equation of the line that goes directly in the middle of the parabola. And it basically cuts it in half. So that would be more or less that line. I know that's not perfect, but yeah, it'd be more or less around there. So we've got to find what this value here of x is, okay? And you do have a formula in your formula booklet for the axis of symmetry, and I have written that down here. Okay, so it is x is equal to negative b divided by 2a. All right, and so in our circumstance here, we have a is equal to negative 1.6, and b is equal to 4.48. And so therefore, the axis of symmetry is going to be x is equal to negative 4.48 over 2 times by negative 1.6, which will turn out to be 4.48 divided by 3.2, or negative 4.48 divided by negative 3.2, same thing. And that comes to, therefore, 1.4. So x is equal to 1.4 is the axis of symmetry. All right, let's move on to part B. Okay, what we got? To prepare an event, a square-based crate that is 1.6 meters wide and 2 meters high is to be moved through the archway into the ballroom. The crate must remain upright while it is being moved. Determine whether the crate will fit through the archway. Justify your answer. Okay, cool. So we're told that this crate is 1.6 meters wide and 2 meters high. Okay, so we're going to be graphing on our calculator. All right, but before we do that, I just want to sort of illustrate what we're going to be doing. Okay, so we're going to graph our graph, negative 1.6 x squared plus 4.48 x, and we'll get the same shape as this here. Okay, then we're also going to graph the line y equals 2, which is going to sort of draw a horizontal line across the ballroom at a height of 2 meters. Okay, so let's say if that was, let's say roughly that's going to be here. Okay, let's say that's roughly there, and we'll say that this is at 2 meters. Now, if the difference in x from this point here to this point here, how about we call this x1 and x2? Now, if x2 minus x1 is more than 1.6, okay, so aka more than the width of the crate, then we're good, okay? Therefore, crate fits. Okay, and if it doesn't, okay, so if we bring this down and we say it is less than 1.6, we'll write crate doesn't fit. Okay, and so then that will be our conclusion. All right, so let's go find this out, and I'm going to bring you over to Desmos. It's slightly easier to visualize, but do find out how to do these graphs and find these intercepts in your own calculator. Okay, so okay, here we are, and so our graph is 1.6 x squared plus 4.48 x. Now we're not concerned about obviously it going below the x-axis. In fact, we can get rid of that. We'll go for y is more than 0. Oh, more than 0. Yeah, we need to do that, and then put y equals here, right? Yeah, there we go. All right, cool. So there we have our archway drawn, and now we're going to draw the line of y equals 2, which is going to be like a horizontal line across at 2 meters from the in the ballroom. And now we're going to have a look at these intersections. So we've got 0.5572 and 2.243. All right, if we zoom in on Desmos, you get more decimal places. So 0.5574 and 2.2426. All right, so if we come back to the pad, I'll write this in. Okay, so intersections. Hold on, we'll write this. So find intersections find x intersections of y equals 2 and y is equal to negative 1.6 x squared plus 4.48. Sorry, 4.48 x. Okay, and so we'll say the intersection points here, and we'll go into, let's go into red, are 0.5574, comma 2 and 2.2426, comma 2. All right, and so here we have, let's call this x1. Let's say this is x2. All right, and so then we're going to say, so x2 minus x, oh no, hold on, let's actually write in the numbers. So therefore 2.2426 subtract 0.5574. Let's find what this is equal to. We need a different calculator, bear with me. I'll use this one. 2.2426 subtract 0.5574. So that gives us 1.6852. 0.6852, which is greater than 1.6, okay, which we set up above, all right, up here. So that is greater than 1.6 meters, okay, so therefore we will conclude the crate will fit. Right, and so that is the answer to part B. And I thought it could be interesting to actually visualize this, the crate fitting through in Desmos. So what we'll do, we'll come back to our graph. Okay, let's zoom out a tad if it wants to do that for me. Okay, how kind. I've lost my mouse. There we go. Okay, cool. Now what we can say, if we were to go from 0.6 to 2.2, that would have a width of 1.6 meters. So how about we write that in? We'll say y has to be less than 2 meters, so less than 2 meters, but between this, so from 0.6 x to 2.2, and that is that, and then we'll make sure that y doesn't go below 0, and so it's actually 0.6, beg your pardon. There we go. Okay, and so now you can kind of visually see, this green square here is a the crate, which is 2 meters high and has a width of 1.6 meters, and it will just fit. It's not a lot of wriggle room there, but it does. Okay, so there you go. That is the answer to question 11, question 12, beg your pardon, with a little bit of an extra illustration at the end to show you what it would look like with the crate going through the archway. Okay, there you go. Question 13. Juliana plans to invest money for 10 years in an account paying 3.5% interest compounded annually. She expects the annual inflation rate to be 2% per year throughout the 10-year period. Juliana would like her investment to be worth a real value of $4,000 compared to current values at the end of the 10-year period. She is considering two options. Option 1, make a one-time investment at the start of the 10-year period. Option 2, invest $1,000 at the start of the 10-year period, and then invest X dollars into the account at the end of each year, including the first and last years. Okay, part A asks for option 1, determine the minimum amount Juliana would need to invest. Give your answer to the nearest dollar. Okay, so let's take in some important info. So we've got 10 years here. 10 years is our time frame. We've got 3.5% compound interest compounded annually in the account. And we've got an inflation rate of 2% per year. Annual inflation rate of 2%. Yeah, okay. Throughout the 10-year period. Okay, and very important bit of info here is this idea of a real value of $4,000. Okay, compared to current values. And we need to find the minimum amount for option 1, minimum amount Juliana would need to invest, such that she has this real value of $4,000 at the end. Okay, so for this, we will need the compound interest formula, which is in your formula booklet, and I have written that down here. Okay, so where this FV stands for future value, PV stands for the present value, R is the interest rate, okay, as a number, all right, not converted to a decimal or anything. So if the interest rate is 6%, you put 6 in here, okay. That's dividing by 100 is the thing that converts that percentage then into a decimal, right? So you don't have to worry about converting the interest rate into a decimal. That's the formula kind of does that for you. Yeah, so then divided by 100K, and K is the number of compounding periods per year. So in the AI course, you will have annually, half yearly, monthly, quarterly, and then monthly. Okay, so those are the 4 options. So that means K can take the value of 1, 2, 4, or 12. Okay, so for the most part, then there could be variations on that, but for the most part, those will be the 4 main options that you'll get. And now that's raised to the power of K, which we just talked about, multiplied by N, which is the number of years. Okay, so for this question, the tricky part comes into play when we have this idea of the real value of 4,000. Okay, and essentially what that means is we're going to have to adjust this future value for inflation, okay, for this 2% inflation. Okay, so therefore our future value in this equation here is going to be our 4,000, but then adjusted for inflation, which is 2%. So then that's going to be 1 plus 2 over 100. Now we were told it's annually, so K is going to be 1. I'm going to put 1 in here just so you can see what would happen if, let's say, if K, so if K is 1, you don't have to put this in, you don't have to put the 1 there. Though if it is not, then you definitely, I would say remember it. So that's why I'm going to be quite pedantic here and put everything in. And then this is going to be raised to the power of 1 multiplied by 10. Okay, so just basically 10. And this is going to equal the present value, which we're trying to find, okay, multiplied by our interest rate, or our annual interest rate in the bank account where she's investing the money, which is 1 plus, so the interest rate was 3.5% divided by 100. So again, I'm going to put 1 in there, although it wouldn't be necessary for you to do that in your exam, but, and yeah, there we have our formula, our equation. Now we just have to rearrange this for the present value, okay? And so the way we'll do that is we'll say PV, the present value, is going to be equal to 4,000 multiplied by all this, but I'm going to take this and we can clean it up. Let's get rid of the ones and to the power of 10. Let's make this smaller, bring this over to here. Okay, all right. And then divided by this here. In fact, no, I will actually show you what this will turn into if we were just to write it as a decimal. So 1 plus 2 over 100 to the power of 10, we could change to being 1.02 to the power of 10. Okay, so just to show you, this thing here, what I've just written, is the same as this bit here, right? It's just sort of cleaned up a bit. And all right, and now then this is going to be divided by essentially this, what I've just brought down here. Okay, but then if I want to make that slightly cleaner, what we can do is call it 1.035. Now let me bring that down. I've got no room for my power, to the power of 10. Okay, cool. And so there we have our present value calculation. And so if we put this into our calculator, we will get 4,000 times by 1.02 to the power of 10 divided by 1.035 to the power of 10, which gives us an answer of $3,456 dollars and 67 cents, let's say. But what we'll do is we'll write 3,456.67 and then rounded to the nearest dollar as we're told. And we're in dollars, so always a good idea to put the unit in as well. So we'll say $3,457. Okay. Now, quickly before I move on, I've noticed that an alternative way to calculate this, which is accepted in the mark scheme, though is technically slightly wrong, is if you just take the difference between the inflation rates, okay, which would be 3.5 subtract 2, okay, which will give us 1.5. Now, if we do that though in our calculation here, and we go sort of 4,000 divided by 1.015 to the power of 10, you'll see that gives us $3,446, okay, dollars. So it's very close to being correct, though it is slightly off. But I will say that this is actually an accepted answer as well in the mark scheme. Both of these were accepted. The one that I've done here is more accurate, though that method there is also accepted. All right, but yeah, we're going to stick with this because that is more precise, more correct. Okay, so let's move on to part B. All right, for option 2, find the minimum value of X that Juliana would need to invest each year. Give your answer to the nearest dollar. Now, in order to calculate this, you're going to need to know how to use the finance solver on your calculator, on your GDC. Okay, so same again, it'll all be, every calculator will be slightly different, although the process and the fields in which we need to put our values will be somewhat, they'll be similar. They'll be similar, but the process on how to get there could be different for each calculator. So if you're unsure on how to do this in your own calculator, just follow a YouTube tutorial or Google it, and there should be something up there that should help you out. Okay, so over to the calculator. So on this one, we need to go to the financial section, okay? And then we get a list of all these different financial applications we can use. So for this question, we need, and for the most part, what you'll be using is the compound interest function here. Right, and so here we have a list of inputs that we need to put in. So you'll always leave one blank because that's the one you'll be solving, okay? So N stands for the number of payments, okay, made throughout the whole period, okay? And in this question, we're told that she is making annual payments for 10 years. Okay, so that means there are 10 payments, right? So if, just to give you a different example, if it was, let's say, quarterly payments for 10 years, then the number of payments would be 40. Okay, it would be 4 payments every year for 10 years. But for this one, we've got annual payments for 10 years. Now, our interest rate was 3.5%. Okay. The present value, okay, of, so the way we need to now consider the present value and the future value of what we need to put in is we need to think about it in cash flow terms. Okay, so at the start, our question says that our option 2 says she will invest $1,000 at the start of the 10-year period. Now, if we're thinking as if we are Juliana, okay, that means we are paying $1,000. Okay, so this, what we're going to put in here is negative 1,000. You can think of it as if you were the bank. Let's say you could say you're the bank and you're going to be receiving it, but just make sure that for the next terms that we talk about, that you keep the same frame of mind, whether you're coming at it from the perspective of being bank or being Juliana. I tend to stick with the person, or the subject of the question, which is Juliana, and so she is paying $1,000 to the bank at the start. Okay, and the future value here, right? So this is what we were calculating before, all right, in our part A, which was the $4,000 of real value. So hence real value, aka adjusted for inflation, which will mean we need to multiply this by 1.02, which is the inflation rate, to the power of 10. All right. So then now that gives us the future value adjusted for inflation. She invests $1,000 at the start, so that's the present value of the account. Got the interest rate, number of payments. Then another thing you're going to have to make sure here, which is on this calculator, it's a little bit hidden, but you're going to have to make sure that the payment date is the same, okay, or is correct. So in option 2, we were told that she invests $1,000 at the start of the 10-year period, and then invests X dollars into the account at the end of each year. Okay, so that means we have to put end there, all right, rather than begin. It'll be quite clear if it is begin, because it will say beginning of each year. All right, and so there we go. And now we've got to go to the payment bit and put solve. And there we have our answer. Okay, so negative $295.39. This negative bit means that Juliana is the one paying the bank. Okay, if we wanted to come at it from the perspective of the bank, okay, if we wanted to think we're the bank, the future value is going to be what we pay to Juliana. So we'd have to put that as a negative, and we'll put the present value as a positive. All right, so that means we're receiving it, we're the bank. All right, and then if we solve this, you'll see the what have I done over here? The same amount comes up, but it's positive. Okay, so that's all kind of thinking of it as if you're the bank and you are receiving these $295 payments, right? So you can come at it from either frame of mind, but you just have to be consistent between the two, all right? And the inputs that you're putting in. Now let's so here we have the answer. That's 295.39. Okay, so let's come over back to the pad, and here we are. Cool, very nice. And so using our finance solver, actually what I might do is I'm gonna take a screenshot here for us. Let's plug it in. Okay, there we go. And so therefore the payment is equal to $295 rounded to the nearest dollar. Okay, there we go. And I didn't talk about these bit here, but this is The P/Y is payments per year. Okay, so that's one. And C/Y is the compounding periods per year. Okay, so both of them stayed as one. Yeah, I hope that helps. And yeah, all the best. That is the answer to question 13.